Good afternoon, class. How are you? Okay, please come on with arrangement. My name is Mika Bishop. I'm teaching in scientific principles. Before we move on, I want to know if all of you are in. James? Elliot? Present. Sarah? Alexis? Present. So he's not around. He's just a group. Please sign. So we are going to look at what's called scientific principles. So at the end of the page of the exercise book, write the learning outcome which you are supposed to learn at the end of this lesson. Right? And the learning that we're looking at is to discuss scientific principles. Today it is on dates. In the fact. At the end of this lesson, you are supposed to know the following. If fine, you are supposed to write it in the exercise at the end, okay? And one is we need to do conversion of units. But when you are in high school, you learn about in physics, okay? Example, we did physics in high school. Learn about basic and derived quantities. And you are told basic quantities are just quantities like temperature. It doesn't depend on something. But derived quantities, these are quantities that you need to add or subtract or you multiply with two quantities so that you get, for example, the area of a cylinder, the volume of a cube. Those are derived quantities because you derive from two measurements, either length, width, and the length is what is called the basic quantity. So first of all, let's divide the basic quantity. That K, then derived quantities. Write it down. You are somewhere, or I write it down. Basic quantities. International system of units. Based on units from all other measurements. For example, length, strength, mass, temperature, and temperature. The basic quantities derived are SI, that is the International System of Units. That are derived from basic quantities, such as volume, density, and area. Now, measurement of the SI unit for length. Start from the SI unit for length is in meters, right? The unit symbol is capital. a unit for mass is in kilograms. And it's simple is in kilograms. There's a unit for temperature is what? Degrees what? Celsius. Now, for derived quantities, we say these quantities we derived from where? From basic. So you cannot be able to get volume directly. You must multiply two measurements. Because you know the volume in mathematics is length times width times height. That is the volume of a cylinder. I mean of a cuboid, right? But the volume of a cylinder is given by what? For example, is take derived quantities. Volume of a cuboid. This is length, width, and this is the height. So to get volume, which is our derived quantity, is given by length times width times height. And the answer on the unit at the end, you should get either in centimeter cube or in meters cube. It should be cube because it is of 3 measurement. Right? Now, take an example. If you have been given the measurement of a cuboid, example, measurement of a cuboid is being given. Centimeter, 2 centimeter, 2 centimeter. Find volume. Uwe naona kidogo ndio wengine wakusikilize. So volume of a cuboid is also length and this width and this height, which is equal to we have length as 10 centimeters multiplied by 3 centimeters multiplied by 2 centimeters. So, for calculator, well, calculator, just a simple, it is like this, 10, that equals to 60. So, I'm having 60 cubic centimeters. Yeah, my coffee. That is how that thing is calculated. Okay? But bear in mind, because it is in physical work, we are finding volume, and that volume in physical work is what is called derived. We derived from the length, the width, and the height of that cuboid. That is the measurement, right? Now, there is another derived quantity called density. Density is the thickness of a fluid. Kama ile uji, kuna maji, kuna maziwa, na pia ni density. What in other words, tunasema density ni kama ile how thick it is, that fluid. For example, wakati unaweka uji kwa kibuyu, una sapati na lazima because its density is higher than that of water, right? So the density when you're in high school, because it is based in high school, density miaka wapi the density. Kuna swali na okay, density. symbol is O. So this is density. Now, when you calculated mass, volume, with the density, they are actually related. So you draw a triangle like this, then unaikata hapa katikati, unaweka mass hapa juu, unaweka density chini, then cross volume. Sawa? So wakati unaambiwa tafuta the density which is at the right quantity, unashika D, which is mass over what? Sawa? So density, which is basically that, is actually equals to mass over volume. And the SI unit for mass is what? Is in kilograms. And the SI unit for volume, it is in meters cubed. So the SI unit for density must give you something in kilograms per meter cubed. Per mean volume. So now let's do an example. You've been given a cylinder of radius 7 centimeter and height of 3 meters. kilograms. Sasa mass ni uzito, sawa? It's like weight, but weight and mass are different. So mass ni uzito. So that mass, wakati when you measure the mass of that cylinder, it is 14 kilograms. And the radius of that cylinder is 7 meters. And for the height of that cylinder is 3 meters. You are being told to find the density. Now, are you getting? Yes. Now, unaandika hapa? Now, let's find the solution for that problem. Everything is a problem. So, a problem must have what? A solution. So, we must be able to find the solution for this, for that problem. Na kwa njia rahisi, you draw it, right? You draw it. That cylinder looks like this. From here to here is 3 meters. Katikati hapa mpaka hapa it is 7 meters. Na tumeambiwa the mass, uzito ya hiyo kitu ni nini? 14 kilograms. So we are being told to find the density. Density ndio tunaambiwa tafuta. From our definition, we say density is actually equals to mass all over volume. But we don't know the volume of this cylinder. We must calculate it. Right? So volume of a cylinder is given by what? Pi r square times height. Pi r square, it is what is called the way it was here, the circular part. And then you multiply. You cut up. Unafanya kwa kuchoma. Unafanya. Sasa unasaidia hata ukikata hii kitu hivi. Hii cylinder kukati hivi. Then you stretch it. Itakuwa like that base of hiyo sanduku yenyewe. Sawa? Then also wakati unainua hizo anchors huko juu, you must make it must be 90 degrees. Should not resist. Or 30. Should be 90. Wakati unachomelea. Right? So the volume is that. Pi, we take it to be 22/7. It has been calculated a long time ago. Wale wanafanya hesabu back in Egypt. Times 7 times 3. This is equals to 1 by 7, 1 by 7, 1. 22 times 7 is 150. 4 times 3, 460. 462 centimeters. Cubed. Meters cubed. Meters cubed. Now we have gotten the volume, so we find the density, which is equals to mass, which is 14 kilograms over 462 meters cubed. Utapata ngapi? When you keep the calculator, it should give you 0 point something. 0.03 kilograms per meter cubed. That is the density of your cylinder. Right? Now, can you discuss amongst yourselves how you are supposed to get that thing? Okay. In groups, okay? In groups of 3. Kama sasa nyinyi ni watatu. That cylinder, radius of the cylinder is 7 centimeter and height is 4 centimeter. Mass yake is 64 kilograms. Find the density and discuss. Now you have to discuss among yourselves, right? Utachukua moja atufanyie kwa kama umeshindwa naweza enda kuangalia kule, right? Yes. Mass was 64 16 centimeters cubed. Okay, correct. Naona hawa washapata. Correct. Now you have actually gotten what you are supposed to do, right? Now, the third thing that we are supposed to do because we are going as per our outcomes is the conversion of units. When you are in primary school, you are being taught about how to convert kilograms into meters, into centimeters, into millimeters. Sindio? Na tulikuwa tunaangalia the kilogram hectometer, sindio? Mean kilometer, then decameter, meters, centimeters, millimeters. How do we change it? This is 10, 10, 10, 10, 10, 10. Meaning 1 kilometer. How are you going to convert it to be in meters? You multiply E times C, 100 times C, right? Times 10. Divided by 10 because it is in 10. 1,000 meters. So now, when you want to know about meter, how many meters are in centimeter, you just count. So 10 multiply, right? So I think we have come to the end of the lesson. I want to give you an assignment, right? For you to be able to get and try at home. And your kesho, tuje tunatani tuone if you have got it. Sawa? This is called a follow-up activity. Actually 5 marks of the examination. So you're supposed to do in your leisure time that assignment. Now look, when we started our lesson, we said you're supposed to know 3 things: to define derived quantities and basic quantities. The second thing is now you define the SI unit for basic and derived quantities. And we say basic, these are SI units which are based only in one measurement. For example, length is a basic quantity, time, a basic quantity, temperature, a basic quantity, mass, a basic quantity. But derived quantities, these are quantities that are derived from basic quantity, right? So you cannot be able to get the volume just because you have the length. You must have 3 measurements so that you get the volume. The same way applies here. And then the conversion. You use this formula, right? For you to be able to convert the units, 1 unit into another, and vice versa.